Space is vast. It's filled with galaxies, stars, and planets. We look up at the night sky and wonder, what else is out there? What secrets does the universe hold? The universe is full of mysteries, some more baffling than others. Black holes are one of these mysteries. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. For decades, scientists have been fascinated by black holes. These cosmic objects challenge our understanding of physics. They push the limits of our imagination. Imagine a place where the fabric of space-time is bent to its breaking point. That's a black hole. Recently, astronomers made an incredible discovery. They found a black hole unlike any other. It's a giant, a monster lurking in the heart of a distant galaxy. This black hole is so massive that it makes our own galaxy's central black hole look like a tiny speck of dust. This discovery is a game changer. It forces us to rethink what we know about black holes. It raises profound questions about the nature of our universe. Join me as we journey to the edge of space and time. Let's explore the mysteries of this colossal black hole and its implications for our understanding of the cosmos. Black holes are born from the death throes of massive stars. When a star runs out of fuel, it collapses under its own gravity. This collapse creates a singularity, a point of infinite density. Around the singularity is the event horizon, the point of no return. Anything that crosses the event horizon is lost forever. It's pulled in by the black hole's immense gravity. Not even light can escape this gravitational pull. This is why black holes are black. They don't emit any light that we can detect. For years, black holes were theoretical objects. Scientists predicted their existence based on Einstein's theory of general relativity. However, observing a black hole directly is impossible. They are invisible to our telescopes. So how do we know they exist? Scientists infer their presence through their effects on nearby objects. Black holes have a powerful gravitational pull. This pull affects the movement of stars and gas clouds around them. Enter the recently discovered black hole. This behemoth resides in a galaxy billions of light years away. It dwarfs all other known black holes. Its mass is billions of times greater than our Sun. This discovery was made possible by a global network of telescopes. These telescopes work together, combining their power. They form a virtual telescope the size of Earth. This technique, called Very Long Baseline Interferometry, VLBI, allows astronomers to observe objects in unprecedented detail. The VLBI observations revealed a bright ring of light around the black hole. This ring is known as the accretion disk. It's made up of gas and dust spiraling into the black hole. As the material falls in, heats up and emits radiation. The size and shape of the accretion disk provided crucial clues. They allowed astronomers to calculate the black hole's mass. The results were astounding. This black hole was a giant, unlike anything seen before. To grasp the scale of this black hole, imagine our solar system. The Sun sits at the center with the planets orbiting around it. Now replace the Sun with this supermassive black hole. Its event horizon would extend far beyond the orbit of Pluto. This immense size has profound implications. It means that this black hole has been growing for billions of years. It has been swallowing up matter from its surroundings, constantly increasing its mass. The discovery of such a massive black hole so early in the universe is puzzling. Current theories struggle to explain how it could have grown so large so quickly. It suggests that we may need to revise our understanding of black hole formation and evolution. The discovery of this colossal black hole has opened up new avenues of research. Scientists are eager to learn more about its properties. They want to understand its impact on its host galaxy. One area of interest is the black hole's spin. As a black hole rotates, it drags space-time around it. This effect, called frame dragging, can be observed by studying the orbits of objects close to the black hole. Another focus of research is the black hole's jets. These are powerful beams of energy and matter that blast out from the poles of some black holes. Scientists believe that these jets are powered by the black hole's spin and magnetic fields. Studying this massive black hole can also teach us about the early universe. The light we observe from it has traveled for billions of years to reach us. It carries with it information about the conditions of the universe when it was much younger. By analyzing this light, scientists can learn about the formation and evolution of galaxies. They can study the properties of the first stars and the conditions under which they formed. This black hole acts as a cosmic time capsule, providing a glimpse into the distant past. Furthermore, this discovery has implications for the search for extraterrestrial life. The conditions around supermassive black holes are extreme. However, some scientists speculate that life could exist in their vicinity. Or what lies beyond the event horizon of a black hole? This is a question that has intrigued scientists and philosophers for decades. Einstein's theory of general relativity predicts that at the center of a black hole lies a singularity. This is a point of infinite density and zero volume where the laws of physics break down. However, some physicists believe that quantum mechanics, the theory that governs the behavior of matter at the atomic and subatomic levels, may play a role in what happens at the singularity. They speculate that quantum effects could prevent the singularity from forming, leading to a different outcome. One possibility is that black holes are not bottomless pits, but rather gateways to other universes or dimensions. This idea, known as the wormhole hypothesis, suggests that black holes could be connected to white holes, hypothetical objects that spew out matter and energy. Some theoretical physicists have proposed a mind-boggling idea that our entire universe might exist inside a black hole. This theory is based on the observation that the universe is expanding at an accelerating rate. This expansion could be explained if our universe is situated within the event horizon of a much larger black hole. According to this theory, the Big Bang, the event that marked the beginning of our universe, could have been the result of a massive star collapsing into a black hole in a higher dimensional universe. As this black hole formed, it created our universe within its event horizon. While this idea is highly speculative and there is currently no direct evidence to support it, it highlights the profound and often counterintuitive nature of black holes and their potential implications for our understanding of the cosmos. The discovery of this exceptionally large black hole is just the beginning. It has raised more questions than it has answered. Astronomers are eager to find more of these cosmic giants. They want to study them in greater detail. New telescopes and technologies are being developed. These tools will allow us to probe deeper into the universe. We will be able to unlock the secrets of black holes. The quest to understand these enigmatic objects is a testament to human curiosity. Black holes remind us of the vastness and mystery of the cosmos. They challenge us to expand our knowledge. They inspire us to explore the unknown. As we continue to explore, we can be sure that the universe will continue to surprise and amaze us.